So we're back with the chain rule, and this time we're going to throw some trig in with it. Oh, our favorite fun trig functions and derivatives and chain rule all rolled into one. Can you hear the excitement in my voice? All right, let's see what we got here. Remember the chain rule. It's for composite functions, and if we're given a composite function and we take the derivative of the function, the outside function, the inside function stays the same. And then we take the derivative of that inside function. Well, how does that work with trig? If I look down here at this example, f of x equals sine of x to the fourth. So that kind of looks like a chain rule, doesn't it? We have just a quantity to an exponent, and it does. So we could say what the g of x is the sine of x, and we could say that h of x was x to the fourth, and if I find h of g of x, or h of g of x, I'm taking my g of x function, putting it in there, and that would give me the sine of x to the fourth. So we do have a composite function, don't we? And you can think of it being broken up that way, or we can think of it as just a quantity to an exponent, in this case, where we have 4, the inside is going to stay the same, sine of x, decrease your exponent by 1, and then the derivative of the inside. Derivative of sine of x is our cosine of x. And that's going to give us what our derivative is. Could rewrite this maybe for cosines of x times the sine of x to the third, or sine cubed of x if you want. So that doesn't bother us probably too much. What's going to bother us though is when we take the sine of maybe an angle that's not just x. And that's really the crux of what we're wanting to get through today. So can we find the derivative of the sine of 2x? Well, again, this is a composite function, isn't it? We could say g of x is 2x, h of x is the sine of x, and again, I could find the h of g of x. I'll tell us to take 2x and plug it in for x, so that would give us the sine of 2x, wouldn't it? So we do have a composite function there. So how can we find the derivative of this? Well, again, we're going to take the derivative of the outside function. So the outside function here are h of x. So it's going to be the derivative of the sine of x. Derivative of sine of x, we remember, or we saw up here, was the cosine of x, but we don't have just x, we have the cosine of 2x. That inside function didn't change. And then we have to take the derivative of that inside function, of that angle. So 2. So I guess what we have to remember is that when we take the derivative of a trig function to an angle and not to x, we have to take the derivative of the trig function, the angle does not change, and then we take the derivative of the angle. Remember to multiply by the derivative of the angle. That's where a lot of people get caught up. So we take the derivative of the trig function, the angle stays the same, we multiply by the derivative of the angle. So we can write that as 2 cosines of 2x. Please do not multiply that 2x and the 2 together. This 2x is the angle, this 2 is the derivative of that angle measure. So here, just going to run through a few more examples here. We have the sine of 2x, the square root of that, so we can rewrite that as the quantity of the sine of 2x to the 1/2. So this is kind of interesting because we have a composite function, kind of two composite functions here. So we have a quantity to an exponent, so that we're going to bring the 1/2 to the front. The inside is going to stay the same, so the sine of 2x, take the angle, or sorry, the exponent, decrease it by 1. And then we got to take the derivative of the inside. Well, derivative of the inside, we have the derivative of a trig function to an angle that's not just x. So we have another chain rule in there. So derivative of sine of x, or this derivative of sine of 2x, is cosine of 2x, then times derivative of the angle, which is 2. So here we see we have a chain rule within a chain rule. Be very careful and make sure that you step out what we've got there. So we've got here now 1/2 times the sine of 2x to the negative 1/2 times the cosine of 2x times 2. So the 1/2 and the 2, they're going to cancel each other out. We have the cosine of 2x over the sine of 2x to the 1/2 power of the square root of sine of 2x if you wish. And that gives us our answer. So example, I don't know what example we are on. This next example, we'll call it f prime of x. So here we have the cosine of an angle squared. So notice we don't have the entire thing squared, so we don't have something like our previous example where we have our exponent coming to the front within our chain rule. So here we take the derivative of the cosine of x. Derivative of the cosine of x is the negative sine, not of x though. Our angle is actually pi x squared. And then we got to take the derivative of that angle. The derivative of this angle, here we have a power rule. So we're bringing the 2 to the front, or actually a chain rule in there, which we have a power rule within it. So we have pi 2 times pi x to the first, and then derivative of pi x, which is pi. Then we can go ahead and clean this up. Again, we cannot multiply this pi x squared with this stuff here. This here is all being multiplied to the front. So we can write it as negative 2 pi squared x sine of pi x squared. And that would be our first derivative. Let's see, I got 2 more examples here if we want to play with them. Let's see, again, we have this h of x equals g of the tangent of x. Oh, isn't that fun? We want to find h prime of pi over 3 given g prime of these things here. So, let's go ahead and find h prime of x. What do we have here? We have g prime of the tangent of x times, what do we got here? Times the derivative of the tangent of x, which is the secant squared of x. So now we can go ahead and find h prime of the pi over 3. Well, what is h prime of the pi over 3? Well, we got to find g prime of the tangent of pi over 3 times the secant squared of pi over 3. Well, can we go ahead and find that? And hopefully, yes, we can. So we got to go back to our unit circle. We're looking at pi over 3. If you need, hopefully you don't need it, but that's going to be pi over 6, or sorry, pi over 3 is going to be a 60-degree angle, if you need that reference. So what is this point over here? We're coming over 1/2, and we're coming up radical 3 over 2. So the tangent is, we'll come up here, tangent. Hopefully, again, if you remember all this, you don't have to worry about it. But if you don't, that's where we have to come back to our unit circle and figure out what it is. So what's the tangent of pi over 3? Well, that's sine over cosine. Sine is the y value. So we have radical 3 over 2 divided by 1/2, which gives us radical 3. So we have g prime of radical 3. And then we're going to find the secant squared of pi over 3. Well, what's the secant of pi over 3? Well, secant, again, let's see, what do we know about secant of x? Secant of x is, yes, 1 over cosine of x, isn't it? So we have 1 over cosine of x, so secant squared of x is going to be 1 over the cosine squared of x. Cosine, again, remember, is the x value. So at 60 degrees, we're at pi over 3. We're at 1/2 there. So we have the secant squared of pi over 3 is going to equal 1 over 1/2 squared, or 1/4, which is 4. Well, now what are we looking for? G prime of radical 3. G prime of radical 3 is -1. And we're multiplying that to 4, so we end up with a -4 value. So that, again, would be a nice AP kind of question because it requires you to remember your unit circle, remember the tangent, how to find the tangent value, and how to find the secant value. So a lot of good stuff in that one question, as well as testing that chain rule for us. Last one, f of x equals sine squared of x minus cosine squared of x. I'm not sure why I made that the last one there, but make more sense if that was the last one, doesn't it? So here we're subtracting 2, so we have 2 chain rules separate of each other. Derivative of sine of x, we have 2 sine of x cosines of x. From that, we're going to subtract. Derivative of cosine of square root of x is going to be 2. Again, the inside angle cosine of x is going to stay the same. Derivative of cosine is negative sine of x. So it looks like we have the negative 2 cosine of x times the negative sine of x gives us a positive 2 sine of x cosine of x. So simplifying, we get 4 sine of x cosine of x as our first derivative. And there we go. There's some examples of our chain rule with our trig functions. I know you're all so excited. Good luck!